Okay, here we go. Second part. We are starting at question 13 where we left off. So I want you to hit pause and press play when you are ready. Okay, so we need to describe fully the single transformation that maps A to B. So we can see that it is a enlargement. So we would write that and we would check out our edges. We've got 1 going to 3, so it's a scale factor of 3. When it comes to the last step, finding the center of enlargement, we have those rays that go through the corners, and then they will cross and meet at a point. You can also work on finding that staircase. It's a scale factor 3, so it's got to be a 3-step staircase. Not quite so easy doing that one backwards, but for some people, they find that easier. So it's just good to have options, isn't it? So that was the answer to question 13. Question 14, pause, press play when you're ready. Okay, so we've got A, which is 5, 4, minus 2 lots of B. So we times the whole lot of B up twice. So we've got 6, 4. And then 5 minus 6 is minus 1. 4 minus 4 is 0. And that is it. All right, that is the answer. Question 15. So there's 2 parts to that. Do both bits and then press play when you are ready. Okay, so we need to work out what n is, and so we really kind of need them on the same side. So the smaller set will land as minus 16n. So 21 take away 16 is 5n, and that is greater than 15. Divide through by the 5, and you have got n is greater than 3 as your final answer. On the number line, you have got to just go steady. Don't just automatically go up minus 3, 5, and use those numbers, because there's a little bit more than just a single x happening here in the middle. So this is going to be 2 equations. We've got minus 3 being less than x plus 3. Now I need x on its own. So across it goes, it lands as minus 3. So I've got minus 6 being less than x. And then I repeat that process on the other side. I've got x plus 3 less than 5. 1x on its own. So take off the 3, and I've got x is less than 2. And then these two kind of come together to give me minus 6, x, and then 2. I don't have any equal parts, so I'll go to the minus 6, I'll go to the 2, keep the circles open and join them up. That's a grade 5 question. So hopefully you remembered that and that went well. They're not overly common, but it's a really nice thing to be able to do. Okay, question 16. We're going to do some indices. So hit pause, press play when you're ready. Okay, so tidying along the top, we've got 3 plus 5 is 8, plus 1 is 9. So I've got m to the 9, that's using my times rule, divided by m to the 3. And my divide rule is take the powers. So I've got m to the 6 as my final answer. Now with this question, you just need to take your time, basically. Do the numbers. I've got 24 divided by 8. Well, 24 divided by 8 is 3. I've then got my a's. So I have got a to the 4 divided by a to the 3. If you want, and I think it's good practice anyway, just write down what you're doing. It just takes the eyes away from all the busyness of the question and helps it just focus on what you're doing. A divide question is take away the powers. So you've just got a to the 1. And then the same again, you've got b to the minus 2 divided by b to the 5. The rule is to take, so I've got minus 2 take minus 7, which gives me b to the minus 7 as my final answer there. Okay, Well done if that went according to plan. Okay, read through carefully and hit play when you're ready. Okay, so my keywords here are that these are mathematically similar. So the smaller of the trapeziums, because I've got two just kind of slotted on top of each other, but the smaller one is being multiplied up by something to create the bigger one. So I'm going to use my boxes and labels. I'm going to find, well, I'll put my labels on first. I've got the small shape and the bigger shape. And then I'm going to the diagram to find, you know, the numbers that are going to help me. So this edge and this edge, okay, are the same edges for each shape. So they're my fact, my pair that goes together. 11.25 is in the small column and 18 is in the big column, side by side, really, really important. The only other information that I have is my E to A, which is the edge of my small shape. They want me to find A to B, which is the same corresponding shape, you know, edge. So it's all good, it all works. So I'm going to put in my 6, making sure I get it on that small column. If I put it in the wrong place, then the boxes and labels aren't going to help you organize the numbers anyway. So that's my trap number, 11.25. I've got 18 on the top and I times it through by 6. I pop that into my calculator and I've got 9.6 centimeters as that missing length. Now, you don't have to use boxes and labels. It's just a great way to structure the numbers and make sure that you're doing them in the right way. Okay, question 18. There you go. Hit pause, press play when you're ready. Right, so here's a concrete block. It has a density of, and you know what? I don't even have to read any further before my brain is starting to work. It's triggering against that word density, and I'm drawing before I even worry about anything else. You know what? It could be once I carry on reading, I don't need this, but I'm just in that zone. I've got density, so I know mass, density, volume. Mum's on top. So concrete blocks, it's got a density of 2.3. I've got to work out the mass. So this is what I've got to find. So mass is found by doing density times the volume. And I've got to give my answer in kilograms. Okay, so there's a lot going on again with this question because my density, if you take a little look, is in grams per centimeters cubed. I'm matching centimeters here, but they do want my answer in kilograms. So I do need to be very, very careful and mindful of that. All right. So density, I go to the question. I've got that number. It is 2.3. I got to times it by the volume. I go to the question. I don't have the volume. So at this point, I've got to reevaluate. Okay, what am I looking at? What do I know? I know that the volume is the area of the front face times by the third length. My front face is quite an odd shape. It is that. And obviously, my third length is the 20. So I need to be working over here on my front face. So I'm going to pop a split in. It doesn't matter whether I go across or down. I'm going to go across. I can see then that this section here, I just color it in. This section here is going to be found by doing 6 times 12. And then this top section is 5. And then I'm missing that little bit there that I need. The whole of this is 8. If that bit there is 6, the whole of that is 8, then that will be 2. So I know that it's also going to be 5 times 2. And it's going to be these two things that are added together. So first of all, my 6 times 12 is 72. That is 10, giving me a total front face of 82. So this here is 82. 82 times 20 is 1,640. Okay, so that is the volume. That is my centimeters cubed. That is my volume. So I can now take that and I can use it over here where I wanted the volume in the first place. So I'm going to time through by 1640. That is going to give me 3772. Now, this is where it's really important that we've clocked our units, okay? The density is in grams, which means this result is in grams, okay? Our question wants it in kilograms. There is 1 kilogram to 1,000 grams. So I now just need to divide this through by 1,000, and I've got 3.772 kilograms. So again, just details to be watching out for. So when you're doing these types of questions, you know, you read them, you reread them, check in and make sure that you are doing what they are asking. So hopefully that went well. And we are picking up marks. And again, these are 4-mark questions. There's marks all over it. So if you're ticking parts, if you didn't get it right, but you're going, well, I did that bit and I did that bit, you know you are getting marks. All right. All right. Next question is question 19. So hit pause and press play when you're ready. Okay, so we've been asked to find the area. So the most sensible split to do here is probably straight across. And we've got our a triangle and we have got our rectangle. I can get straight in on that rectangle. The area of that is the base times the height, 16 times 8, which is 128. I know that the base of this triangle is 16. Area of a triangle is base times height divided by 2. I've got that base, 16, and I do not have a height. Remember that this diagonal is not making a right angle. There is no H for height. Okay, heights are perpendicular. Heights are the very tallest point coming straight down and making that right angle. Okay, so I'm just going to remove this 16 and actually put that height in. It's coming straight down and it's making a right angle. That's why I call it H for height, because the right angle makes a kind of H looking shape, doesn't it? Now that the symmetry, you've got obviously a 10 and a 10, you know, this is perfect symmetry. And I've created 2 right angle triangles. I have a height here that I don't know, but I do know that due to the symmetry, this is 8 and this is 8. And I can get my Pythag into this so that it can save the day, okay? So just considering one of the triangles, I have got 10 here, I have got 8 here, and that's what I'm looking for, okay? I'm going to be using a squared plus b squared equals c squared to solve it. My right angle points to my A and my B. So obviously I don't have A, I have H. So I'll call it H squared, why not? Could have left it as A squared, it really doesn't matter. And then I've got my 8 squared equaling 10 squared. So H squared plus 64 equals 100. Now we get H on its own, take the 64 off, and I've got H squared is equal to 36. Square root that, and I've got a height of 6. Okay, so I can go back up to my triangle work now. I've got 16 times the height now, which is 6. So 16 times 6, and then divide that by 2, all right, which is going to give me 48. So the 2 areas, I've got 128 for the rectangle, I've got 48 for for my triangle, giving me a total of 176 centimeters squared. And this one is the type of question that you might very well see on a non-calculator paper. The Pythag were square numbers that we knew, so they were easy to process. They came out with a whole number, not a horrible decimal. So this definitely is the sort of thing that if they're going to do Pythag on a non-calculator paper, then they're going to do it where the numbers are doable by hand. All right. Okay, question 20. Pause and press play when you're ready. All right, so this one isn't a million miles away from one that we've seen during the sessions. It was in the last one, but the total surface area of a cube is 96, and you have to work out the volume. Now, first thing I would do is draw a picture. If they don't give me a diagram, I draw one, because it is how I work. You know, when we're working in maths, we're working with numbers and we're working with diagrams. We're not working with sentences. So the more I can put this together into a diagram to hinge my thinking against, the better. So I know a cube is looking something like that. It's not a brilliant picture, but it does the job. I know that a cube has edges that are all the same. So those edges are the same. The third length is the same. The edges are all equal. The surface area are the faces added together. So I know that this face here is the same as all the other faces. What I don't know is what the edge is. I know that x times x, I know that x times x would give me the area of that face. I also know there's 6 identical faces. So I know that if I times it through by 6, that's all the faces considered. And then obviously I know that the surface area is 96 because they've told me it is. So to finish this off, I'm going to just write this with a power 2 because that will be easier for me to work with as well. And then I can bring this across, divide that through. So I've got x squared equaling, once I divided the 96 by 6, I would get 16. Square root that, and my x is equal to 4. So that's just told me the edges. All right, it hasn't answered my question, which is work out the volume. So now I'm going to be doing the area of the front face times by the third length. So the front face is a square, it's 4 times 4 times through the third length, and you've got 4 times 4 times 4, 64 centimeters cubed. Okay. Hopefully that went reasonably well. They are harder questions. They are, okay. But as long as you're giving them a really good go, that's grade 5. There's a lot of thinking. You're almost writing your own algebra, aren't you? So it's a big deal. It really is a big deal. All right, your next question is that one. So hit pause and press play when you're ready. All right, so we've got a nice little solve. So I'm going to rewrite it so I've got a bit more space. We're going to get rid of that. It's going to land as -5. So I've got 8y being greater than 4. I'm then going to divide through by the 8 so that I've got y is greater than 4 over 8. It doesn't say how I have to leave my answer. Y is on its own, so that is the answer. However, it might be nice, certainly if you've got a calculator, because it will do it for you anyway. It's also nice just to cancel these things down. So y is greater to 1/2 or 0.5. Okay, and then write down the inequality. So we have got -4, we have got 5. The letter we've been given is x. It does not equal the 5, but it does equal the -4. So that is that one. Next question. So hit pause, press play when you're ready. Okay, so the rule is to add. So we've got y to the 8. The rule is to take. So 6 minus -2 creates that positive. So I end up with t to the 8. Here I've got to remember not just to do the power rule, but to do the 2 cubed. So 2 cubed is 8. So 8 is the numerical part of my answer. And then a power to a power is multiply. So I've got n to the 12 as my final answer there. And anything to the 0 is 1. Okay, question 23. So this is our last question. It's a big one. Okay, it is a big question. So again, I want you to just, I mean, even take a break if you want to before you do this, but I really want you to go for it. It's another big question, lots of maths to do. I want you to think about everything. What am I looking at? What are they telling me? What do I know? How do I use it? And just pull through the question using those to try and tease your knowledge out and be able to give that a really good go. So press pause and hit play when you are ready. Okay, so I have got a picture of a cushion. All right. I have to remember that there are 8 of them, because once I get into this question, there's going to be so much work going on the one cushion. By the time I finish, I'll think I'm done when actually there's still more to do. Okay. So I've got a patio with 8 identical cushions, and there are the dimensions given to me in centimeters. The cushions are coated in a protective spray, and each I think that's supposed to say can, each can of protective spray covers 6 meters squared. And it's really important I pick up on that as early as possible, because I don't want to be in different units. And actually, if the cans are in meters squared, then I really probably need to work in meters squared right from the off. So if they're covering the cushions, then it's the surface of the cushions that's involved in this question. And I therefore want to be finding the surface area of those cushions. I'm also going to be doing that in the unit meters. All right. So this is going to change to 0.95, 0.85, and 0.22. All right. So the top of my cuboid, basically, or my cushion, all right, is 0.95. And I'm going to times that through by 0.85. And I know that the bottom is identical, so I'm going to go straight in with timesing that by 2, put that in my calculator, and I've got that for the top and the bottom now, yeah? So I've done both. Next one I'm going to do is the side. So the side is 0.95 again, but this time it's only going up 0.22. And obviously I've got 2 sides, so I'm going to times by 2 and just get that coming straight out. I've then got the front, which is 0.85 times 0.22. There is a back as well, times that by 2. And I've got 0.374. Add that up and I've got my total surface area, which is 2.407. Now remember, that is just 1. Okay, I have 8. So the next thing to do is to times this through by 8. Obviously, we're doing this in a calculator, not by hand. The calculator is giving me 19.256. So the last part now is to work out basically how many 6s are going to go into that. Now you could divide that through by 6. So 19.256 divided by 6 is giving me 3.2. I can't go in and say, I want 3 cans and just a little bit of another one. I'm going to have to go in and buy 4 cans to get the job done. If you don't divide it through by 6, you kind of don't need to. In a way, you could sort of say, right, well, 6 times 3 cans, I'd make it clear that I'm working in cans, is going to cover 18 meters squared. So that's not enough. I need 4. Anything that communicates your thinking is going to work and keep your examiner happy. All right. So I think they're big questions, not as bad as that cuboid and cube right at the beginning. I think that was probably the hardest one, wasn't it? But that is it. That is it. You are done. So I obviously, oh, I lied. There's another one. I am cracking up. You'll be glad it's the end of the course, won't you? All right, we're going to do this question and then it's the end of the course, I think. Okay, hit pause, press play when you're ready. Okay, there is your answer. So lots to consider actually with this one. So you were given the center and it was marked on for you, which was nice because it did mean that you didn't have to then start, with a wrong coordinate or anything. Multiplying up by 2.5 was going to give us a kind of fraction where we weren't literally in the corner of a square, we were halfway along. It's good to see that actually, because sometimes we feel like that's wrong, but obviously it's not at all. You could have a go at the steps. You can sort of see what I've tried to demo there. In fact, I'll make it a little bit bigger so you can see it really well. You can see that I've gone up once, I've gone up twice, and then this is a half movement. Okay, so it's half the size of the other steps. So that is one good way of doing that. Or you can just go through with your vectors in the first place and they will sort it out for you as well. Okay. I think that's the end of the course. Shall we look? No, you can tell. Seriously, congratulations. All right. These courses aren't written to make life particularly easy, are they? They are hard. I know they're hard, but they are preparing you for the unknown. We know that we're going to go into our examinations and we're going to be seeing questions we've never seen before. So it's really important that we're not trying to learn to pass those exams by recognizing questions. It can't be, oh, I've seen this before, which means I know what I'm doing, super confident. It's always got to be right. It's a question. I know it's a question I've not seen before, but what do I do? What do I know? How can I use it? All of that is going to help you. I really, really do hope that you have found the course beneficial. I hope that when you think about the progress you've made on these topics, where you were at the very, very beginning to where you are now, that's your true measure of progress. It's not about whether you are getting 100% of everything you do right. Obviously, we want to be getting better and getting those marks, but equally, we've got to be kind, because if we're not kind, we can end up just being mean and telling ourselves that we're not as good as maybe we actually are. Progress is progress. And if you know for a fact that you feel way more confident than you did at the beginning, then you have done a good job. Remember, you have these videos for 12 months. You can watch them, rewatch them. You can go through those consolidations again anytime you like. You can leave it a month if you've got time. I don't know how soon you're doing these in front of the exams, but you could leave it ages and then just go back and go, right, what can I remember? Because we know as we're building more and more knowledge, other bits start to fall behind and we have to come back and try them again. As I say, I hope you have enjoyed. Hope we have helped you in your journey with the maths. Good luck if you are getting ready for those exams. And if we can help with any more courses, please do get in touch. Again, really, really well done. Not an easy course.